Okay, Assalamualaikum and hi everyone. So we meet again. So now I want to discuss about reaction quotient. The symbol here is Q. Alright, so what is reaction quotient? Right. So this one is calculated by substituting the initial concentration or pressures of the reactant and products into Kc or Kp expression. So let's say we have this equation, alright. So as we already learned before this, the Kc expression is this. This is the Kc expression. So the concentration for each of the reactant and the product for the Kc is referred to the equilibrium concentration. However, for the Qc, each of the product and reactant here, so it's referred to any initial concentration. So that's why not here, the symbol not here is referred to the initial concentration. Okay, right. Okay, next, the question here is, how do you know if the reaction has reached equilibrium? Okay, so what should we do? So you must compare the value of K and Q. Alright, so when comparing, so we should get three cases. Okay, three cases whether Q is smaller than K, or Q is bigger than K, or Q is equal to K. So what is the meaning by these three cases? Alright, so now we refer to this. Okay, alright, so if when you calculate, then you get Q is smaller than K. So Q is smaller, which means the concentration of the reactant is bigger, whereas for the concentration of the product is smaller. Okay, so the system is not at equilibrium since reactant or denominator is large relative to the numerator products. So therefore, to reach equilibrium, which refer to Q is equals to K, the product must increase and the reactant should be decreased. So how to do that? So the net reaction will progress to the right. So in order to form more products. So which means shift to the right here. Okay, shift to the right. Okay, so until equilibrium is reached where Q is equals to K. Right, so if Q is bigger than K, so Q is bigger, which means the concentration of the reactant K is smaller and the concentration of the product is bigger. So which means the system is not at equilibrium because of the reactant or the denominator is small relative to the numerator, which refer to the products. Okay, how to achieve Q equals to K? To achieve equilibrium, product must decrease and reactant should increase. Okay, so therefore the net reaction will progress to the left. Okay, so in order to form more reactant. Okay, until the equilibrium is reached, Q is equals to K. Alright, so if Q is equal to K, so the system is already at equilibrium. So when the reactant and product concentration or pressure has attained their equilibrium values. So therefore there is no further net change. Okay. Right, so this is summary of the comparing Q and K. So if Q is bigger than K, right? So meaning that the product is too large. So therefore, the reaction will proceed or shift to the left in order to form more reactants. Okay. As for Q is less than K, which means the reactant is too large. So therefore, reaction will shift to the right in order to form more products. If Q is equals to K, which means the system is already at equilibrium. Okay, and then no further net change. Right. Okay, so this is in view in graph, right? So when Q is not equals to K, so whether Q is smaller than K or Q is bigger than K, alright, so the system is not reach equilibrium, is somewhere here, okay. However, when the system reach equilibrium, let's say at this T here, okay, so the value of Q is equals to the value of K. Okay. So once equilibrium is reached and any time thereafter Q is equals to K. Right? Okay. Right. So we take a look at this example here. Okay, Kc for the following nitrosyl chloride and an orange yellow compound from nitric oxide and molecular chlorine. Okay, so this is the value of Kc here. Ini Kc. Okay, in certain experiment, okay, so giving to you the initial mole for NO, initial mole for Cl2, and initial mole for the NOCl. Also the volume of the flask. So question asks, in which direction will the system proceed to reach equilibrium? So what should we do? So we have to calculate the initial concentration for both reactant here and the product. Okay. So this is the sample calculation. Okay, so we can write the QC expression. So this is the QC expression. Okay, so initial concentration is not given, so we have to calculate. So for the concentration of NOCl, so you will get 3.4. Don't forget to write the unit molar. Okay, for NO concentration here, suppose you get 0.01 molar. Okay, as for the Cl2, we'll get here 0.004 molar. Okay, right, next step. So just substitute into the QC expression, then you get the value of QC is 2.8 times 10 power negative 7. Okay, the next step, compare with QC that is larger than KC. So which means QC is larger. Okay, which means concentration of the reactant is smaller, concentration of product is bigger. Okay, right. So therefore the reaction is not at equilibrium, and then it will proceed to the left side. Okay, because the concentration of both reactant is low, concentration of the product is high. So the equilibrium will shift to the left in order to form more reactants. Okay. Right, so one more example here. Okay, so given to you the Kp value. So this is example of Kp. Okay, in one experiment, 0.2 atm HBr, 0.01 atm of H2, and 0.01 atm of Br2 are introduced into a container. Is the system at equilibrium? The second question, if not, in which direction it will proceed? So given in the question here is referring to the initial pressure for each of the gas. Initial pressure. So what should we do? So we can write the QP expression like this. This is the QP expression. Next, substitute all the partial pressures. Then we get QP is equals to 2.5 times 10 power negative 3. So remember, QC, QP have no unit. Alright, so then compare with KP. So we can see that the value of QP is bigger, which means the concentration, the partial pressure of the reactant is lower, while the concentration of the product is high. So this is lower, this is high. Right, so which means the reaction should proceed to the system is not at equilibrium. So this is for the answer for the first question. And which direction? So of course, it will shift to the left side. Okay, left side in order to form more reactants. So that the pressure of reactant will increase. Okay. Right. So one more question here. Okay. So given to the chloromethane formed by the reaction here. So we're given to the Kp value in the reaction mixture. So these are all the partial pressure for each of the gases. Okay, so is CH4Cl or CH4 is forming, right? So we can see clearly here CH3Cl. This is referred to the product. Okay, so CH4 is referred to the reactant. So meaning that in the other word, this question asks you the direction of the equilibrium. Okay, so what should we do? So first of all, we have to write the QP expression like this. Then substitute all the values. Then you get here QP is 24.8. Compare it with KP. So we can find out the QP value is 24.8 is smaller than KP. So it's smaller, which means the partial pressure of the reactant is high. However, the partial pressure of the product is low. So this is high, this is low. So the reaction is not at equilibrium, because Q is not equal to K. Q is smaller than K. So therefore, which direction that it will proceed? Alright, since the partial pressure for both reactant are high, so therefore the system will proceed to the right in order to increase the pressure of the products. So because it shift to the product side, so therefore it will form more CH3Cl. Okay, so now we take a look at the tutorial. One is already discussed. So we take a look at tutorial number 2. Okay, at 430, the equilibrium constant Kc for the reversible reaction is this value of Kc. And then given to you only the initial mole for each of the gas and also the volume. So is the system at equilibrium? Then you have to explain. So first of all, what should you do? You have to calculate the initial concentration for each of the gases. So 0.04 moles divided by 2 liter. So we get here 0.02 molar. Okay, as for the H2, 0.01 moles over 2 liter. Okay, so here suppose you get 0.005 molar. Okay, as for the initial concentration of I2, 0.03 moles over 2 liter. Suppose you get here 0.015. Okay, the next step, what should we do? So we have to write the QC expression. So concentration of HI squared over concentration of H2 times concentration of I2. Okay, substitute all the values. So 0.02 squared over 0.005 times 0.015. So when you calculate, suppose you get here, so we get here 5.33. Okay, the next step, compare it with Kc expression, Kc value. So we can see that here, so the value of Qc is bigger than Kc. So what is meaning by that? So if the QC is bigger, which means the concentration of both reactant is lower. whereas for the concentration of the product is high. Okay, so which one is this is low, low, this is high. So therefore the system is not at equilibrium and it will proceed to the left side. Okay, in order to form more right turn. Okay, left side. Okay, so we right. So system. Okay, so for the question number 3, this one is already discussed. So this one from the notes. Okay. Okay, that's all for today. Thank you and assalamualaikum.